Good morning, everybody. Lovely to see almost all of you in today, which is great. If you wouldn't mind giving me some green check marks, please, to get started. And for those of you who've been in for a couple minutes, just out of my curiosity, yesterday when Mrs. Ward was in here, you guys had a bunch of static when she left the room. Did you guys just experience static right now? Because I just left the studio, head to my office. I'm just interested to see if you guys had a bunch of static on your audio. No, it was pretty good. No, that's weird. Maybe she might have left one of them on or something, a mic, and it ended up getting staticky. I'm not sure, but if you guys didn't get any static, then I guess I don't have to worry about it. So my office is apparently close enough that it shouldn't matter much. All right, it's been a few days since we've met. I think it's almost been a week now. Unfortunately, last week I was not able to make it, and then last class I logged in on time, and then there was only like one person in, and then I think somebody else trickled in after a few minutes, and then after about 10 minutes somebody else trickled in. So I just want to express the importance of coming to class. If you want to just work at your own pace, this isn't the program for you. You guys have signed up to be, logged into class, and I appreciate those of you who were here yesterday, and I thank them very much for showing up and apologized. I don't want to have to do that again. So check the schedule, make sure you guys are here. Somebody in the last class said, "Hey, Mr. Borden," I think it was Ian actually, he said, "Is it always going to be the foundations class first?" And I said, "Well, we probably should rotate them so the people that are in foundations can sleep in for a while and then, switch it back and forth." So we'll probably rotate how the blocks show up, so you won't be sitting there kind of bored, although you probably have lots and lots of work to do. So I'm missing checks from Kaylin, Jesse. I think Jesse's probably not there. Jonah's likely not there either. Yeah, internet can be bad from time to time. So, that's why it's important to start logging into class about 5 minutes early. I know when I teach at KSS and we have 30 students logging into Blackboard at the same time, it can take up to 5 minutes or so to get everyone logged in. It just takes a while for everything to process. So when you are trying to get into Blackboard, it's important that you give yourself some time. If class starts at 9, don't log in at 9. Log in at 8:55. Another thing that you can do is, if you're relying on the Wi-Fi in your house, what you can do is just grab a cable and plug your computer right into your modem. Maybe your modem's not in the best spot. I don't know. But it'll make it a lot easier for you to not encounter problems. So if your Wi-Fi isn't good in your house, I know mine isn't. Our router is down in our basement, and then upstairs on the far side of the house, we don't have internet, and it's just a pain. So if I know I'm doing something that I need really reliable internet, what I'll do is I'll just grab my computer, plug it right into my router using an Ethernet cable, and then I don't have to worry about Wi-Fi. Most computers will just switch over right away. Perfect. So I think everyone who's here is giving me green check marks. Yeah. Most of you guys, Jonah's logged in here, but he's likely not here. This is Hurricane Matthew. It's kind of rolling through the Caribbean right now, and this is kind of Cuba, and then under the hurricane is Haiti and Dominican Republic. And this was Jonah's message that he sent me yesterday. "Currently in Haiti, huge hurricane is coming, so I'm losing connection, and it's going to hit us right away. It may last a while, so if I'm not showing up for a class, handing my work, that's my excuse." Ironically, Jonah was in class yesterday and in class again today after going through surviving essentially a hurricane that killed 11 people. So that was his excuse, and he didn't even need to use it. And a lot of you guys, unfortunately, weren't in class yesterday. So it's important that if you're not in class, you have a reason to not be in class. And that reason needs to be expressed to us, either myself, Mrs. Ward, or Mrs. Wood, depending on what class you're missing. This hurricane, that's a great excuse to not come to class. Something other than that, I'm not sure. Not sure that that would be a good enough excuse. So it was just kind of amazing that he's in Haiti and survived this hurricane, and it's Category 4, pretty serious stuff. He made it, and he made it to class yesterday and today. I'm not sure how, but he did it. So there you go. That was a great excuse. If you guys can come up with better than Hurricane Matthew is rolling through my neighborhood right now, then I'd happy to go with it. Yeah, down in the Caribbean. It's about to run into kind of like they've evacuated or starting evacuated kind of like Florida and then up the eastern seaboard a little bit, because it's going to make landfall as a Category 4 in the States in the next few days. I think they said on Friday likely. So pretty serious stuff. Killed 11 people so far, and thankfully Jonah's doing okay. So there you go. Hurricane Matthew. All right, what did I want to talk about today? Let's jump into math. Actually, I'm going to just look at the course here for a second. Just kind of let you guys know where we're at and where we're going. And I would really like to wrap up this unit. I won't see you guys again until next week. So you have essentially one thing left to do. Now, we've kind of been piecing together parts of this unit, Unit 3 linear measurement, comparing systems of measurement, converting between systems. Really, these two are kind of the meat of what we're doing. And then there's kind of like this surface area volume stuff, or sorry, just surface area types of questions. The conversions happens again in this volume section at the end. It kind of probably should have been up here with Unit 2. So we've kind of gone through all of this comparing systems of measurement. We've gone through calculating surface area a little bit. I'll do maybe a few more questions today, but what I want to do today is volume. So if you didn't arrive at class last day, what I said was please go through calculating surface area of 3D shapes on your own. We got to keep moving. We can't just kind of wait. So calculate the surface area of 3D shapes, and then I'm going to get through as much of the volume stuff as I can today. Costin, just reading your message. I watched the videos and they didn't cover everything. So one thing that, I don't love the course and how it's put together in Moodle here, but it is what it is. Some of the questions that you're going to run into involve the same ideas, but they're not written in the same sort of format. So I know there was, I'll just go to it, the example of the logs. Number 4 here. Kelly has to purchase a load of cedar timbers. There's like 26 logs, 28 logs, 2 coats of stain. Gives you the cost, it gives you the tax. It's this big ordeal to get this kind of question done, and you likely haven't seen the exact question being done. I think this one actually is in the lesson. But some of the stuff we've covered, like the surface area of a log that's 10 by 10 by 10 feet, so 10 inches by 10 inches by 10 feet. That's going to be something you know how to calculate the surface area of. A log, like a square rectangular prism shaped timber is just basically like a box. And it's a hard question. It frustrates me a little bit when I see a question like this, because I know you guys get frustrated with it. There's just so many steps. You have to find the surface area of one log. Once you've done that, you need to multiply by 28. Once you've done that, you need to figure out how much paint is needed. Not once, but you need to do it to get 2 coats of paint, so you need to double the paint. And then you need to figure out, okay, this is how much paint I need. Now I need to multiply it by how much per container of paint. And then once I've done all that, I have to add 5% GST on top of it. So it's like literally about a 7 or 8 step problem, and they just kind of throw it at you and say, good luck guys, you'll get it. And then they kind of insult you by saying, okay, I'll do one exactly the same, and then I'll ask you to do another one, but it's not a log anymore now. There's a room with a door in it, and I don't know. I don't love the course, but it is what it is. So we just need to kind of work through it and just do your best to try to get these answers. Know that when you guys start to do the quizzes and tests, there's going to be really easy questions, and then there might be one or two really hard questions. But the majority of the test questions you're going to encounter are going to be fairly straightforward, and then there's always going to be a couple that are like the challenging ones. So just remember that. Keep that in mind. It doesn't necessarily make anything better, but it's all right. I suppose it'll be okay. I was reading through this lovely document here. It's called the Apprenticeship in Workplace Mathematics, Grade 10. It's called the Integrated Resource Package, so it's all of the things you need to learn. And I was kind of looking through it and explain how the imperial system was developed. And I'm like, well, I haven't really covered how the imperial system was developed. Identify commonly used units in the imperial system and determine the relationship among the related units. So I'm thinking, I have to talk about how the imperial system was developed, and then I have to explain kind of the relationships between the units. And I don't really know a lot about the imperial system. I mean, I grew up in a time in Canada where the metric system was common, and I really kind of get frustrated with the imperial system because it doesn't make any sense to me. So what I did was I found a little video that I feel does a really, really good job of explaining the difference between the parts of the imperial system and how the things are related and where sort of the imperial system came from and things like that. So I'm going to get you guys to watch it. I'll throw the link into chat and you can just click on it. Sometimes I'll try to play it here and then hold my mics close so the audio plays. But I'll just throw the link in because that's just going to be easier. So let's just watch through this now, and then we'll do a couple of examples, and then I'll see if you guys have any questions. So it's actually quite a good video. It's only a couple minutes long, and I'd like you guys to just watch it, and then give me a green check mark once you have finished watching it, and then we'll just talk about it for a second. So there you go. Give you 2 minutes, 50 seconds to watch the video. Green check when you're done, please. Just give you guys a second to finish up the video. A few of you put in some checks, but some of you might still be loading that. So I'll just a few more seconds here. Gotta love how these computers just kind of always want to sabotage what we're doing. Costin, you can't watch because YouTube's blocked on your computer. Is that like a setting, or is it just like your Adobe's out of date? A really common problem with YouTube is if your Adobe's out of date, it says plugin is vulnerable, please update your plugin, whatever. I think it was Jeremy was in here the other day and he was having that issue on his computer, and in the top left corner next to the URL of your web address, right up here where this little green lock is, sometimes there'll be a little red, it almost looks like a Lego block, and you can click on it and go allow now and the video will play. So if that's kind of a problem you're running into, you can usually allow the videos to play and then update your plugins or whatever later. Galen, I think your comment kind of really summed everything up quite well. That was outrageously confusing. And that's how I feel when I think of, like, we talked a little bit about it when we first introduced these ideas. The United States, Liberia, and Burma, or Myanmar, are the three countries left in the world that are still on the imperial system. Now the UK is a little bit different because they're kind of moving back and forth and they don't really know what they want. But the whole imperial system, it just makes my head hurt because it's just so bizarre how everything is related. And I was watching some other videos while I was trying to find this one. This was kind of like the best to show you guys, I thought. But some of these other videos explained how, like a lot of these measurements originally came from Egypt, and there was kind of kings and queens along the way in the UK who decided, I think it was one king, I think it was Henry I, decided a yard was the distance from his the tip of his fingers to his nose. That was a yard because he was the king. And it's just kind of like these measurements make no sense. And then the UK has measurements of mass of stones. Like most of the stuff in that video was just measuring length, but mass is measured in stones. So they literally would take rocks and then kind of weigh it out. But a stone in one part of the UK would be different than a stone somewhere else in the UK, and everyone had different stones. And then the United States adopted the imperial system because of the British coming over, and then they changed their definitions of miles and pints and all of this stuff, and it just kind of like all of this other stuff. So it's just crazy, absolutely crazy. And I get really frustrated when I do these conversions. You know how much easier it would be if the United States would just switch over and then we wouldn't have to worry about imperial anymore. Everyone else in the world's on metric. And then often students ask, Mr. Borden, why is this important? Why do I care about this? Well, other than the fact that you're likely going to encounter metric imperial stuff for the rest of your life, I'm going to give you guys an example of why the metric imperial kind of debate is really important. In 1998, there was a orbiter called the Mars Climate Orbiter. It was sent to Mars to measure the Martian atmosphere and do a bunch of different calculations and measurements and learn more about Mars. And I forget how much it costs. It was right here. The cost of the mission was $327.6 million, $193.1 million for the spacecraft, $91.7 million for launching it, and $42.8 million for mission operations. So we're talking $327.6 million. So why am I bringing this up? Well, NASA, the smart people that exist at NASA, they do everything in metric because the rest of the world's metric. They do a lot of stuff with the Russians because the Russians launch astronauts for NASA now and things like that. So everyone deals in metric. Awesome. For this particular mission, they used a contractor, Lockheed Martin, which is kind of a big aerospace contractor in the United States, and the United States uses the imperial system. So NASA says to Lockheed Martin, hey, Lockheed Martin, do all of your calculations in metric because that's important. And then Lockheed Martin decides that they kind of forgot and they're in the United States, so they're going to do everything in imperial. And what happened was, just really quickly here, they wrote some software that used a unit in pounds feet per second instead of Newton seconds, and the orbiter took in this information in imperial units, and what happened was this $327 million satellite crashed into Mars, burning up, wasting $300 million in a few blazing seconds of glory. So the problems between conversions, they do exist in real world, and this is a very expensive example of why it matters. $327 million. I would have been happy to take that money off of their hands if they were just going to burn some stuff. I could have lit a piece of paper on fire or something for them. Anyways, that was a few years ago. Heck, that was a long time ago, 1998. Most of you guys were born in year 2000, is that right? Is anybody born in the 90s still? Are we all 2000s now? Any 99ers? 98ers? You guys will all be 15, 16 this year. You're going to be 2000 or 2001s, are you not? 2001, yeah. That's crazy to me. That makes me feel really old. I look at 1998 and I think that was just yesterday. Now I know how Mr. Ross feels next to me here. He's no spring chicken, we'll just leave it at that. You're all in the 2000s. That's it. I'm officially old. Wow. You guys weren't even born in the same millennium as me. Oh, all right, let's go do some math. Yeah, I mean, with media and whatnot, all the 90s stuff is available at your fingertips, but there you go. Crazy to think that. All right, so I asked you guys to go through some of these surface area volume questions on your own. I left you kind of last week with this example 4 with a load of lumber and whatnot. I would really like it if you just tried this question. And when I say try, all I want to see is that you have put in an honest effort and that there is some calculations that kind of maybe make sense, finding the area of things. With a question like number 4, it's really long and there's lots of parts. So if I'm looking at your work, I should be able to identify what I'm looking at. It shouldn't just be a bunch of random numbers. So if you need to write down like surface area of paint and then have a little spot for that, then write it down. You need to be able to communicate clearly what you are trying to do. Now, I'm not so concerned with you ending up with the exact correct answer. What I'm concerned with is how you're trying to get there. Are the steps you're taking the right steps to end up where you need to end up? And, you know, is your thinking correct? Is your logic correct? The math is important, but it's not as important as the steps that you need to do along the way. So try number 4. It's a tough question. That's okay. Do what you can there. Costin's good question. When is this stuff due, Mr. Borden? We're just going to work through it. I want to go through some of the volume stuff today, and then we will give you guys some time. We'll just see how far we get. I'm not going to put a due date on it and say it's due on Monday, because I don't know how far I'm going to get today. But I will be very, very clear that things need to be done at particular times. So my hope is that you're continually working through this learning guide. Last class, I left you with the idea that you needed to work through the surface area and volume of 3D shapes. which is coming up down here where it says Unit 3, Lesson 4, page 7. Try this. So this is a cylinder. So what I'm going to do is I'm going to just cross off a few questions. If you've done them already, no worries. I'll mark them. But if you haven't done them, then don't worry about it. So example 5 is the same as the one above it. This is, of course, we don't have page numbers. This will be the third page. So we did this one with the turf. I asked you to do number 2, and then this little table you guys have done already. I had asked you to do number 4, and then on the next page, don't worry about number 5 or 6. So this is on the page with the cylinder at the bottom. So this is the bottom, this is the top. So don't worry about 5 or 6. I would like you to do these surface area questions though. So label the net, and remember a net is like if you cut out all the shapes with scissors, what would you end up with? So draw a net for number 7, shouldn't take very long. Determine the surface area of the above cylinder. Make sure you're using your formula sheet. So here's the cylinder, it says surface area formula down here. I'll do this first one to kind of show you what I expect to see out of your work, and then I'll let you guys do a few of the other ones. I'm just going to take a little snip of this, move it over. All right, so let's do this first question here. Of course, I'm already there. Oh, there we go. Okay, got that all sorted out. Oh, of course, it won't let me take that. Oh well. All right, so determine the surface area of the above cylinder if it has a height of 8 and a radius of 3, round to 2 decimal places, and use the pi button on your calculator. So there's a lot of stuff written in there, and this is kind of the expectation of the work I expect on a question like this. So the first one's a cylinder, then it gets into a few pyramids, and I think there's a sphere at the end possibly. So if there's no picture drawn, the first thing you must do is draw a little picture. And I mean, I'm not expecting a masterpiece as long as I can kind of figure things out, but here is my cylinder. Pretty straightforward. It says the height of the cylinder is 8, so I would expect you to label height 8, and then a radius of 3 centimeters. So that's kind of the first thing I would expect you guys to do, is draw a picture of what you're dealing with. In this one, if you labeled the cylinder up above, I would have been fine with that, but there you go. The next thing I would expect you to do is write down a formula. So if you're taking the surface area of a cylinder, you should go to your data book and then find the formula for surface area of a cylinder. So I've done that already. I've kind of taken a little snip of it here. But this is it right here. Surface area, SA, 2 pi r squared plus 2 pi rh. So in the question, I would expect to see an actual formula with no numbers plugged into it. 2 pi r squared plus 2 pi rh. Got it. Perfect. So this is kind of the second thing I will expect to see. A formula with no numbers plugged into it, just the formula. This is the formula for the surface area of a cylinder. And then I kind of want to see you guys plug in the numbers. So 2 times pi, the radius was 3, so instead of r, I'm going to write 3 squared. 2 times pi times 3, and a height of 8. So I've substituted the values in. I'll probably work this out in 2 steps. I was just showing my other math class that I downloaded a fancy calculator to show you guys how to do some of this stuff. I just want to talk about this. Use the pi button on your calculator. Here's my calculator. Look at that. That's pretty cool, isn't it? So 2 times pi times 3 squared. My pi button's way down here at the bottom above this EXP. And in order to get to it, I have to hit the shift button first. And then I have to hit this guy down here. So what I'm going to do is I'm going to plug it in just like I see it. 2 times, and then I have to go second pi times 3. And then I have this squared button here. So I hit that. Now my calculator window shows up with this 2 times pi times 3 squared. So I can do it all in one, or I can do 2 times pi, and then I can multiply that by 3 squared, or 9. In any event, that gives me this 56.548667776. Now, it's important that I keep as many decimal places as I can. I only want to round at the very end. So what I'm going to do is, because my calculator is super duper smart, what I'm going to do is I'm just going to press plus, because that's the next thing I'm doing in my equation here. I'm going to press the plus button, and see how it says answer? That just means whatever the previous answer that shows up in my window was, it's just going to take whatever that is. So I'm going to go, that's really the first half of this question. So I'm going to answer plus, and then I'm going to put this in brackets, because my calculator doesn't know BEDMAS. 2 times pi times 3 times 8. I'm going to close the bracket. I'm going to hit enter. And it's going to give me an answer of 207.3451151. But I'm not going to write that all down. It says 2 decimal places. So 207.345. So because it's a 5, I need to round the second decimal place to a 5. So 207.35. My units were centimeters, and because it's an area, I have centimeters squared. So there you go. The things that I would expect to see on a question are, number 1, I want to see a picture if it's talking about like a shape or something like that. Number 2, I want to see the formula that you're using. And then I want to see you substitute values into the formula, which would be number 3. And then number 4 would be an answer with units. The 3 and the 8 in B. So the radius was the 3 and the height was 8. From the question, it says radius and height. And they're just numbers right out of the question. The R is radius, it says the R is 3, and it says the height is 8, or H is 8. And then just like right here where we had an R, I put in a 3 for R because the radius from the question said it was 3. All right, so those are kind of the 4 things I'd like you guys to show for all of these types of questions. Draw a picture, label the parts, the formula you're using, substitute into the formula, and then an answer with units. That's kind of the minimum. You can do more than that if you want, but it just makes it easier for me to follow and see what you guys are doing. So I did 8. I'd like you to do 9. Let's not worry about 10 for now. I think you guys should be able to do 11. And let's do a cone right now. So Unit 3, Lesson 4, page 9 is referring to a concept no longer in the course. Take a look. Derivation of a cone, anyways, blah, blah, blah. Then move on to the next page. We'll begin our work with cones. So we have to talk a little bit about cones. So I'm just going to jump over to the formula sheet here. And where'd my formula sheet go? There it is. Find the formula for a cone. See right here, surface area is pi r squared plus pi r s. Of course, pi r squared is a circle. Pi r s is the outside. So that's a circle on the bottom. And then this pi r s is kind of the lateral area, called the lateral area. Or the sides, if you want to think of it that way. So we need to kind of label what all of these things are. The radius is going to be the distance from the center to the edge. We're going to call that r. And then the s is going to be the distance from the tippy top to the edge. So as long as you know those two things, you can calculate the surface area of a cone. That's it. All you need is those two things. So we've labeled that diagram. Let's look at this example here. So it says a cone has a radius of 9. There's my cone. It says the radius is 9. And it's inches. And the slant height from the top to the edge is 15 inches. Determine the surface area. So pi r squared is a circle on the bottom, and then the second part was pi r s. So r is the same thing as radius. In this question, it tells me the radius is 9. Pi times the radius again is 9, and then s is the slant height, which is 15. So I've substituted the values from the question into my formula. Pi times r, radius, I need to square that, and then pi times r times s, the radius, and then s is the slant height. So I need to calculate that. I can plug it into my calculator and see what I come up with. So let's go ahead and do that. All right, the first part is pi times 9 squared. Get rid of all this. I'm going to go shift pi, and then I'm going to multiply it by 9, and then squared. I'm going to hit equals, just so it calculates that, and it gives me this 254.469. So that's the first part, and then I'm going to add to that, so I just, on my calculator, because it's really smart, I can hit plus, and it'll take the previous answer, and then I'm going to put a bracket, and then just write in what I see. Pi times 9 times 15. I'm going to close the bracket. and then I'm going to hit enter. And I get 678.58. Now the question says round answer to 1 decimal place, so I'm going to just switch that from 678.58. If I need to round this 1 decimal place, because this is an 8, I need to round this up to a 6. My units were inches, and because it was an area, they need to be inches squared. All right, how do we feel about that? Give me like a thumbs up, thumbs down, smiley face, sad face, anything. Anything to let me know how you guys feel about that. Couple happy faces. Anybody else running into problems or got something different than I did for that question? Costin, one thing that might be coming up is this, did you remember to square the 9 squared? Because if you're not putting the squared in there, you might be running into problems. You might want to break it down into 2 parts as well, Costin. So what I'll do is maybe I'll just look at this part again over here on the side. I'll do it as 2 separate parts. So I'll go pi times 9 squared. I'll just do it quickly. Pi times 9 squared is 254.469 and then I'm going to add to that pi times 9 times 15. So pi times 9 times 15 is 424.115. So we're all right with those two. And then if we add those two together, we get the 678.6. So if you wanted to do it in 2 parts and then add them together, that would be fine as well. Just an additional step. If you figured out your calculator and your calculator is kind of working out for you and you can do it all in your calculator in that 1 step, by all means use your calculator to do it. You're kind of opening yourself up to a lot more mistakes by trying to plug everything into your calculator. But if you know how to use your calculator, then I mean you might as well use it. There's no sense in not using it. I'll do this next one just because it's a little bit tricky, and then I'll leave the rest for you guys to try out. Now, you might have remembered this from before. The question sometimes, we're trying to find the surface area of this cone, but the information we're given isn't the information we need. In the question, or in the formula I should say, we have pi r squared plus pi r s. We need to know what the radius is, which we have. That's good. We also need to know what the slant height is. But unfortunately, this question doesn't give us the slant height. So we just give up? Maybe not. No. We can find it. Does anybody remember how I found that before? Done it a few times now. Give you guys a little hint. Has to do with this shape here. Little right angle on the bottom here. I'm going to redraw it. Well, you guys put in the name of the thing I need to do to get the missing slant height. Tells me this bottom piece is 28 and this height is 45. A really common spot that students will make mistakes is they just look at the question and they see that we have two values. I'm just going to plug those values into my formula and just hope that they're right. But unfortunately, that's not how this works. When you're given values to find the surface area, you need to know what pi and the radius are, and you need to know what pi times the radius times the slant height is. But the question doesn't give us the slant height, so we don't know what this is. We can find it. And the way we need to find it is using the Pythagorean theorem. A squared plus b squared is c squared. Now in this case, it doesn't matter what we call a and b, but this s has to be the c, has to be the longest side of the triangle. So we'll take this 45 squared plus 28 squared, and that's going to be equal to s squared. So we go 45 squared plus 28 squared and hit equals, and I get 2,809. Okay, so I get 2,809 is equal to s squared. But I don't want to know what s squared is, I want to know what just s is. I need to know the slant height so I can figure it out in my formula. So what I'm going to do is I'm going to take the square root of s squared and the square root of 2,809. If I do something to one side of my equation, I must do it to the other side. My calculator is super awesome, so I can go shift square root, which is this guy here. I have to use the shift button to get to it. You might just have a square root button on your calculator. And instead of writing 2,809, because I'm really lazy and that's 4 buttons I have to press, what I can do is if I go shift answer, this A and S down here at the very, 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 very bottom, if I go shift answer, it takes whatever the answer was, so I only have to press 2 buttons instead of 4. I saved myself 2 button presses and I hit answer and I get 53. So the slant height works out to be 53, and I only had to press 3 buttons to get that instead of 5. Just think of how much time I've just saved. So it turns out that the slant height is equal to 53. So unfortunately the question didn't give us slant height, but because I could draw a right angle triangle on the edge of that cone, I could actually figure out what the slant height was just because I knew that I had a right angle triangle. So I can continue on here. Pi, the radius was given to me as 28, so pi r squared plus pi times r. And then instead of using the 45 that the question gives me, which is the height of my cone, I really needed the slant height, which was 53, which I just figured out. So s was 53, which I just found. Let's see if I can't just figure out what that equals. All right, so I'm going to get rid of all this. I'm going to go pi times 28 squared, like that. And I'm going to add to it, I'm going to put it all in brackets because my calculator doesn't know order of operations very well. Pi times 28 times 53, close my bracket, and hit enter. And I get 7,125.1. My units were centimeters, and because it is a surface area, they should be squared. $7,125. So kind of a two-step process to get that when you don't have the slant height. Not the end of the world, but there you be. I'm going to leave you guys with 15, 16, I'm going to cross off 17, so you guys don't need to do 17. And I'm going to cross off 18 as well because we haven't done pyramids yet. So don't worry about 17 and 18 if you haven't done them yet. If you've done them already, awesome. But if not, don't worry about it. Which leaves us with 21 and 22. So we're back to these pyramids. Now I'm going to jump over to my formula sheet again and see if I can find out what the surface area, SA, of a pyramid is. Now, one thing I need to be really, really careful with, sorry, I'll just make this a little bit bigger, is this. This square base pyramid right here is exactly that. It is a pyramid with a square base. The length is B and B. Now, if I jump back to my question, I notice that my pyramid does not have a square base. This is 4 and this is 7. If they were both 4, that would be awesome. Then that would be a square base. But they're not both 4. One's 4 and one's 7, which is something entirely different. So if I go to my formula sheet, I scroll down a little bit further, and I notice that for a general pyramid, so a pyramid without a square base, it says take the area of all the faces and then add them together. So I don't have a fancy formula if I don't have a square base, which is fine, no big deal. We just need to take all the pieces of our triangle and just add them together, or our pyramid. So let's go back. Of course, it takes me to the top. Scrolling down. Don't worry about 17, 18. All right. So I don't have a formula. What I need to do is take the area of the bottom. So I'm going to draw a net of my shape here. So on the very bottom, I have a square, or not a square, I should say a rectangle, which is 4 inches by 7 inches. So that's the bottom. That's this base part here. And then I have some triangles. There's this triangle on the side, which is blue. So I'll draw it here as being a blue triangle. And it says the base is 4, and then I have a height of 5. That's given there. How many of those do I have? Well, I have one on this side, and then I have one on the other side. So I have 2 of those. I also have this triangle on the front, which is 7 by, well, I'm not sure. Just going to check something before I stick my foot in my mouth. What's that going to be? 6.1 squared plus 2 squared . 6.4. Okay, the reason I kind of hesitated here is that I don't know the slant height for this, but I can find it because I have this triangle. It's kind of hard to see here. So from the middle to the edge, which is from the center to this edge, is 2. It tells me that the height of it is 6.1, and I need to find the slant height. So I'm going to have to use the Pythagorean theorem again to figure it out. So I'm going to go 6.1 squared plus 4, or 2 squared. And I get 6.41 is equal to the slant height. I called it C. So instead of this being 5, this is actually 6.41 because it's not a square-based pyramid. All of my slant heights aren't going to be the same. So all I've done here is I've calculated the distance from the top to the middle of the edge, which we called S. The slant height of that is going to be 6.41. So that's what I use that Pythagorean theorem for. All right. Let's find the area of these three shapes now. I have all the information I need. Area is going to be length times width, which is going to be 7 times 4, which is going to be 28. Here the area is going to be base times height divided by 2. My base is 4, my height is 5. 4 times 5 is 20, divided by 2 is going to be 10. And this green guy, the area is going to be the same thing, base times height divided by 2. The base is 7, the height is 6.41. And divided by 2. I can't do that in my head. 7 times 6.41. 22.44. All right, I have my square, which is my bottom, or it's not a square. I need to quit saying square. I have my rectangle, which is my bottom. I have the area of one of my sides, which is 10. I have the area of one of my other sides, which is 22.44. But I don't just have 3 sides. My triangle has my 2 side faces, my 2 other side faces, and then the bottom. So what I need to do is kind of think. If I want to take the surface area, I'm going to have the area of the bottom, which I did in red. Then I'm going to have to add to that 2 times the area of the blue one. And then I'm going to have to add to that 2 times the area of the green one. Because I had 2 of the green triangles, front and back, 2 of the blue triangles, side and side, and then the bottom. So I'm going to plug this all in now, see what I end up with. The area of the bottom was 28. I'm going to add to it 2 times the area of the blue triangle, which was 10. And I'm going to add to that 2 times the area of the green triangle, which was 22.44. And I'm going to add that all together. So I'm going to have 28 plus 20 plus 2 times, I guess I can actually do it, 28 plus 20, which is 2 times 10, plus, and then 2 times 22.44. Close my bracket up. And end up with 92.88. All of my units were inches, and I have a surface area, so I have inches squared. This is outrageous. I like it. All right, I'm going to give you guys a few questions to do for next day. I'd love it if you would look at them and come back with answers that are right, but if you had questions, that would be cool too, because then I could do them for you in class, and then you wouldn't have questions anymore. So, although I've written right over example 22, I'd like you to try example 22. I would also like you to try example 23, but don't do it twice. So just 23A, don't worry about B. I'm confident you guys can do 24. I'm confident you can do 25, 26. 27. 29. Mr. Borden, stop! No, you can do it. And 30A. And that'll take us to volume and capacity. So next day, kind of think about it as homework. You have all weekend to do this. Should maybe throw in, I'll leave it there. So I left you guys with 21, I did. I'd like you to do 22, 23A, don't worry about B, 24, 25, 26, 27, 29, and 30A. And that'll take us into volume, which we'll get to next day. So that will wrap up the surface area stuff. I'd love it if you guys came back with questions next day regarding that, but it would be really great if you guys got all the answers right and you showed all your work and everything along the way. So, Costin, you said, when is this stuff going to be due, Mr. Borden? Likely next day we'll do volume and conversions for volume. And do we only have class once next week? Let's just check. I don't know if Mrs. Wood has the schedule up. Mr. Ross has it for me. Thank you, Mr. Ross. Oh, she does have it up. There we go. She must have done that. So we have math on next Wednesday at 10:20. So that means I won't see you guys for a full week. So we're going to finish off volume next day. And then, so the stuff we'll be doing sounds absolutely bizarre, but in 2 weeks. It's just kind of, you know, we have a few short weeks because of Thanksgiving, and we have some Pro D days and everything else. So you only have 3 days of class next week because we have no Monday. So there you go. It's going to be due in 2 weeks, Costin. Hopefully you can finish it all in that time. So finish those questions I assigned for today. You guys are going to do volume next day. You can get ahead if you want. You have a week. And then we'll just keep going from there. So there you have it. Have a great weekend, I guess. I won't see you. And we'll talk next Wednesday. That's crazy. So take care. See you guys later.